Yeah, hello everyone. Uh, I am Mohan Naik, Assistant Professor, Triple Department, work in Marri Laxman Reddy Institute of Technology and Management. So today I am going to discuss about the basic electrical engineering. The course name is Basic Electrical Engineering. In this course, we have total 5 modules. First one is DC circuits, and second module is AC circuit, and third module transformers, and fourth one is electrical machines, and fifth module is switchgear and batteries. So in this 5 module, first we discuss the DC circuits. First module is DC circuits. So in this DC circuits, we have these are the topics: electrical circuits and electrical circuit elements. Those elements are resistor, inductor and capacitors, and voltage sources and current sources, and Kirchhoff laws, and circuit analysis method and theorems. First, we are going to discuss about the electrical circuit. Circuit is nothing but it is a closed path through which current will flows. So this circuit is a closed path through which the current will flows, and this circuit is consisting of active elements and passive elements. Active elements and passive elements. Passive elements. So these active elements are voltage source and current sources are active element. Active element means which are able to deliver the energy. This is a voltage source which are able to deliver the electrical energy, called as active elements. And passive elements, and other elements are passive elements called resistor, inductor and capacitors. These are the passive elements. Passive elements are able to absorb the electrical energy, called passive elements. It is a combination of, circuit is a combination of active and passive elements, and it should be a closed path. And electrical circuit elements. So circuit elements are resistor, inductor, capacitor and current source and voltage source and power. So first we discuss about the resistor. So resistor is a resistor which is oppose the flow of electron and dissipate the electrical energy in the form of heat. The resistor is oppose the flow of charge and which dissipates the electrical energy in the form of heat. And basic formula for resistor is R equal to rho L by A. The resistor value which is directly proportional to the length, and it is inversely proportional to the, and this value is inversely proportional to the cross section area of the conductor. If they increase the length of the conductor, then the resistor value should be increased. And also this resistor element, the symbol for resistor is this is a symbol for the resistor, and resistor value is also depends on the temperature. If the temperature is rises, if the temperature is increases, then the resistor value also changes. Resistor also changes. It may be increase or decrease based on the material. If the material is or conducting material, if the material is semiconductor material, if the material is semiconductor material, if the materials are semiconductor material, then elements semiconductor element, then it is a negative temperature coefficient. Negative temperature coefficient. If we increase the temperature, then the resistor value should be decrease. So if the all conductors are positive temperature coefficient, all the conductors are positive temperature coefficient with respect to directly proportional to the resistor value. If temperature increase, then resistor value also increases. So, and the units of resistor is ohms. Ohm is a scientist name. So ohm, and symbol for ohm is this one. Resistor which is oppose the flow of charge and dissipate the electrical energy in the form of heat. And next we go for the inductor. Inductor is also called as a coil. Take a certain conductor and twist as a coil. It behaves as a basic inductor. If you can take any conductor and you twist as a coil, it behaves as a basic inductor. It behaves as a basic inductor. So inductor basic formula is L equal to n square mu A by L. So where n is the number of turns, n is the number of turns, and A is the area of the conductor, area of cross section of conductor, and L is the active length of the conductor. L is the length of the conductor. L is the length of the conductor. And this is a symbol for the inductor. And the example for inductor is transformer winding, transformer and motor. Transformer, motor windings are best example for the coil inductor. And inductor is a energy storing device. It not dissipates electrical energy, and inductor stores the energy. And inductor stores the electrical energy in the form of electromagnetic field. The main function of inductor is inductor stores the electrical energy, in the form of electromagnetic field. This is the first property of the inductor. Inductor can store the electrical energy in the form of electromagnetic field, and inductor stores the electrical energy and release the electrical energy. And one more property of inductor is inductor does not allow any sudden change of current. So inductor does not allow any sudden change of current means it is a steady state value. It may be also called as DC current. So inductor does not allow any DC currents. Inductor opposes the sudden change of current, that is a DC current. If the DC supply is applied to the inductor, then the inductor behaves as a short circuit. If the inductor acts as short circuit for inductor acts as short circuit for DC supply. Acts as short circuit for DC supply. So that means it does not allow the DC. If we apply the DC circuit, then inductor for DC supply, inductor acts as short circuit. DC supply, inductor act as a short circuit. So, and also inductor store the electrical, first point is inductor store the electrical energy in the form of electromagnetic field, and inductor does not allow the sudden change of current, and inductor store the energy and inductor release the energy. So that means inductor only allows the AC quantity. So inductor, these are the inductor properties. Next, capacitor. Two parallel plates are separated into a small dielectric medium, and it behaves as a basic capacitor. Take two parallel plates and separate it into a small dielectric medium, then it behaves as a basic capacitor. The capacitor formula is C equal to epsilon A by D. In other way, the capacitor can be written as C equal to Q by V, charge per voltage. Charge per voltage is also called as a capacitor. So the basic capacitor units are farads. And best example for the capacitor is batteries. Batteries are the best example for the capacitors. And the main properties of capacitor is capacitor can store the electrical energy in the form of electrostatic form. Capacitor stores electrical energy. Capacitor store electrical energy in the form of electrostatic form. store the electrical energy in electrostatic form. And capacitor behavior is it can store the energy, it can charge the energy. Capacitor initially charge the energy, electrical energy, and discharge the energy, like battery, mobile battery. Example is battery is the example for the capacitor. And capacitor oppose the sudden changes of capacitor opposes sudden changes of voltages. That means DC, again it is a DC voltage. Inductor oppose the DC current, sudden change of current, and capacitor is oppose sudden change of voltage. If we apply the DC supply to the capacitor, if the capacitor is applied to the DC supply, then it behaves as a open circuit. For sudden change, capacitor will act as a open circuit. Next term is current, electrical current. Current is nothing but the flow of charge is called as flow of charge per unit time is called current, electrical current. So it is written as I equal to dq by dt. Charge per unit time is called as the current, electrical current, and units of electrical current is amperes. We can write electrical current like 10 amperes, 5 amperes, like that. We also written as I equal to charge per time, q by t, charge per time. So in other way, transfer of charge or charge in motion is also called as a electrical current. So these currents are classified into 3 types. One is the steady state current, and varying current, and alternative current. So mostly we are classified into AC current and DC current, and one more type of current is it is a variable DC current. So that is the second one. So steady state current, when the magnitude of the current does not changes with respect to of the time, if the magnitude of the current quantity does not change with respect to of time, that type of current is called as DC current. That is a steady state current. Throughout the time t, the magnitude of the current is constant. That is a DC current. Next one, varying current. When the magnitude of the current changes with respect to the time is called as varying current, but the direction is not changed. The direction is constant, but magnitude value will be changed. Magnitude is changed. So this magnitude may be varies time to time, but the direction is only positive direction. There is no negative direction. So it is a varying DC. So variable DC. That is called as varying current. That is the second one. Next, alternating current. So alternative current is the one whose magnitude value is magnitude and direction both are changes with respect to of the time. That is called as a alternative current, AC current. That is the alternative current. This magnitude value changes, and at the same time direction also changes, positive cycle and negative cycle. So this is a alternative current. So DC currents are classified into 3 types. One is a DC current, and DC variable current, and alternative current, that is a AC current. Next, voltage. Voltage is defined as the work done per unit time. In other way, it is a driving force of the current, and the driving force of current is called as voltage. In other way, the amount of energy required for flow of charge. The amount of energy required for flow of charge is called as a voltage. Energy units are joules. Charge units are coulombs. Joules per coulomb equal to volts. So the amount of energy required for flow of charge is called as a voltage. And units of voltage is volts. We can write 2 volts, 230 volts, 415 volts or 11 kilovolts. Like that we can write the voltage. The voltage formula is V equal to W by Q. Next, power. The rate of flow of charge per unit time is called as, the rate at which the work is done is called as a power. Work done per unit time is called as a power. In other way, power is nothing but product of voltage and current. Already we know the voltage formula, W by Q. Charge per amount of energy required for flow of charge is called as a voltage, and current is nothing but charge per unit time. So these charges are cancelled. Then power formula is power equal to W by T, energy per unit time. The amount of energy, the amount of work done per unit time is called as a power. And units of power is wattage. Watts. Units of power is watts. We can write 10 watts, 16 watts, 100 watts, like that. So this is about the power. So up to now we discussed the basic electrical elements: resistor, inductor and capacitor, and also we discussed the basic electrical terms: voltage, current and power. Voltage and power. Next one is energy. Energy W. Energy is nothing but it is a product of power into time. It is a energy. E equal to power into time. Next, Ohm's law. The statement of Ohm's law is the amount of current flowing through any conductor is directly proportional to the voltage and inversely proportional to the resistor at a constant temperature. According to the Ohm's law, the current flowing through any conductor, the amount of current flowing through any conductor is directly proportional to the voltage and inversely proportional to the resistor at a constant temperature. This is the first form of, this form is called I equal to V by R, is the first form of Ohm's law. In other way, the second form of Ohm's law is V equal to IR. From this we can write V equal to IR. This is called as second form of Ohm's law. And the third form of Ohm's law is we also written as third form of Ohm's law. That is voltage across inductor formula. Voltage across the inductor is VL equal to L into di by dt. This is the third form of Ohm's law. VL equal to L into di by dt, that is a voltage drop across the inductor formula. That is also called as third form of Ohm's law. And fourth form of Ohm's law is IL equal to 1 by L integral V dt. So this form is called as fourth form of Ohm's law. We have total 6 forms of Ohm's law. First form is I equal to V by R, and the second form of Ohm's law is V equal to IR, and third form of Ohm's law is VL equal to L into di by dt, and the fourth form is IL equal to 1 by L integral V dt. And the fifth form of Ohm's law is that is a voltage drop across the capacitor Vc equal to 1 by C, Vc equal to 1 by C integral 1 by C integral I dt. Vc equal to 1 by C integration I dt. And this is called as fifth form. And sixth form of Ohm's law is IC equal to C into dV by dt. IC equal to CV by dV by dt. So these are the 6 forms of Ohm's law. That is voltage current through the resistor is I equal to V by R is the first form, and voltage across resistor is V equal to IR is the second form, and voltage across the inductor VL equal to L into di by dt is the third form of Ohm's law, and current through the inductor is IL equal to 1 by L integration V dt is the fourth form of Ohm's law. And fifth form of Ohm's law is voltage across the capacitor is Vc equal to 1 by C integration V dt is the fifth form, and the sixth form of Ohm's law is IC equal to C into dV by dt. These are the different forms of Ohm's law. And the limitations of Ohm's law. So Ohm's law cannot apply for we cannot apply for non-linear elements. The Ohm's law limitations are we cannot apply the Ohm's law for non-linear elements. So non-linear elements are suppose diode transistors are non-linear element. And also we cannot apply the Ohm's law. These are the limitations. So for non-linear element we cannot apply the Ohm's law. And the second one is for unilateral elements also we cannot apply the Ohm's law. So unilateral elements also we cannot apply the Ohm's law. Again, so the same examples for diode and transistors are unilateral elements. And Ohm's law is applicable only when the temperature is constant, temperature and resistor value is constant. When the resistor value is constant, then only we can apply the Ohm's law. These are the limitations of the Ohm's law. Next, Kirchhoff laws. The Kirchhoff laws are two types. One is the Kirchhoff voltage law and Kirchhoff current law. By using the Kirchhoff voltage law, we can calculate the voltage drop across any branch or any element in a series or parallel circuit. So by using the voltage law, we can calculate the voltage drops across the series branches. And by using Kirchhoff current law, we can calculate the current through the parallel branches. If any number of parallel branches are connected in parallel branch, we can calculate the current through any branches. So that is the advantage of the Kirchhoff current law and Kirchhoff voltage law. First we discuss the Kirchhoff current law. According to this law, the algebraic sum of the currents entering at a particular node is equal to 0. In any circuit, we have a node is nothing but, first what is a node? Node is nothing but it is a connecting point of two or more than two branches. Suppose this is a resistor R1 and this one is a resistor R2. This is the point where two branches are connected. That is called as node. It may be more than two elements also. This is R3. So it may be a two elements or more than two elements combination. Then it is called as a node. So such a node, at this node, this is also a node. For this node, incoming currents are equal to outgoing currents. According to the KCL, we can write the mathematical expression. The algebraic sum of the currents at a particular node is equal to 0. This is the mathematical expression. So for this diagram, so incoming currents are I1 is the incoming. So we represent with plus I1. And also I6 also incoming current, I4 also incoming current, I5, I3, I2 are the outgoing currents. Incoming currents are equal to outgoing current can be written as minus. So the overall we can add all the currents at a particular node, that is equal to 0. This is a Kirchhoff current law. Or in other case we can write incoming currents, these are the I1, I6 are the I4 are the incoming current. Incoming currents are equal to outgoing current. Outgoing currents. Incoming currents are equal to outgoing current. Next, Kirchhoff voltage law. Next one is Kirchhoff voltage law. The statement of Kirchhoff voltage law is the algebraic sum of the voltages in a closed loop is equal to 0. In any closed loop, the sum of all the voltage drops or voltage rises are equal to 0. So mathematically we are writing the algebraic sum of the voltages in any loop equal to 0. At any loop equal to 0. We write the KVL equation. So this equation is minus V4 plus V1 plus V2 plus V3 equal to 0. This is a Kirchhoff voltage law equation, KVL equation. Based on the resistance values, we will get the voltage drop across resistor, that is a VR1 and VR2 or VR3 or V3, that is a voltage drop. So algebraic sum of these voltage drops are equal to supply voltage. Voltage drops are equal to supply energy voltage. Thank you.